the idea of simple linear regression. Simple linear regression is used when you have two quantitative, that is numerical variables, and you want to determine if a linear relationship exists between them. If there is a relationship, regression assumes that the dependent variable y is a linear function of the independent variable x. That is, y is equal to an intercept plus a slope times the x variable plus a term to account for random fluctuations. The first step in regression is to collect sample data from the population and to measure both the x and y values. Using an XY scatter plot, we should confirm visually that the points form a somewhat linear pattern as opposed to a curved or bent one. The basic idea of simple regression is to estimate the relationship between x and y in the population based on the relationship described in the sample, and we do this by identifying the line that best fits the sample data, that is, the line that comes closest to the points overall. We measure error, that is, how far each point is from the line along the y or vertical axis. Since some sample points are above the line and some are below, there will be both positive and negative errors. And to ensure that these don't cancel each other out and make the total distance seem smaller, we square each error and sum them all up. This so-called sum of squared errors measures the total distance of the points to the line. The best line, that is the regression line, is the one that makes this sum of squared errors as small as possible. The slope and intercept of this line can be found using formulas based on sample x and y values, but are usually calculated using software. We call the intercept of this best line b0 and its slope b1. The intercept is the value where the line crosses the y-axis, that is, when x equals 0. And the slope is the rise over run of the line. B0 and B1 are called regression estimates or coefficients. They are sample statistics that estimate the intercept and slope of the line in the population. To determine if there is evidence of a relationship between x and y in the population, we conduct a statistical test for the true slope, which we call beta 1. If beta 1 were equal to 0, a relationship between x and y does not exist. In this case, x could be increased and decreased with no effect on y. If we conclude that the slope beta 1 is probably not equal to 0, then we can describe how x affects y using the line. Similar to other statistical tests, to test beta 1 equal to 0, we look at b1, the estimate of beta 1, and see how far away b1 is from the hypothesized beta 1 of 0, measured in standard deviations. If b1 is too far away from 0, we have evidence that beta 1 is not equal to 0, and thus that there is evidence of a linear relationship in the population. However, if b1 is fairly close to 0 statistically speaking, we conclude that the population slope beta 1 could be equal to 0, and that we may have observed a non-zero b1 in the sample simply because of sampling error.
Created using Powtoon.